Very good afternoon again and welcome back. I've got good news for you. We are going to study again and again Archimedes' principle until we understand it. And actually my good friend Mr. Archimedes, he's brilliant and his principle is actually very easy. You just have to remember one simple concept. I'll tell you what it is. I'll tell you the trick of it. And the good news for you is this, that you can master Archimedes' principle quite easily. So there are two things that I would like to teach you and make sure that you get it at the end of this lesson. That is, by the end of this short period, you would be able to understand much better and understand concretely the meaning of Archimedes' principle. And secondly, you are able to answer calculation problems, solve it easily, by making use of your concept of Archimedes' principle. Again, remember to do output revision. Do not memorize equations upon equations. All you have to know is to remember one thing on Archimedes' principle, and I will guide you through it in a minute. And the best way is to look at a question. Alright? Now have a look at this diagram. It's a very, very simple diagram. In diagram first, second and third diagram, you will notice that we have water. The only difference is that we have this object, this pyramid, the weights are different. Or rather the masses are different, sorry. The first one has a mass of 1 kilogram. The second one has a mass of 2 kilograms. The third one has the mass of 3 kilograms. But we are given in the question that the volume is the same in each case. So the volume of the pyramid in diagram 1, diagram 2, diagram 3, they are all the same. They have the same volume. So that is a very important piece of information for us. Okay, let's read the question again. I have summarized for you. In the diagrams above, three solid metal pyramids, P, Q, and R, they are lowered into the water, completely immersed. The masses of PQR, they are 1 kg, 2 kg, and 3 kg respectively. But all the pyramids have the same volume, every one of them. So there is a buoyant force exerted on each of the pyramid. And we call it FP, FQ, and FR. So which of the following statements is true? FP equals to FQ equals to FR. Number 2, FP smaller than FQ smaller than FR. Number 3, FP bigger than FQ bigger than FR. Okay. So let us now look at the question again and we answer it. In my last lesson, I remember asking you to write down a very important concept in Archimedes' principle. Let us recall, let us revise it again. Alright? Now, in Archimedes' principle, very plainly put, it is this. Remember that the buoyant force what is it equal to? It is equal to the weight of the liquid displaced. And in this case, it is equal to the weight of the water displaced. Weight of water displaced. Excuse me, did it say buoyant force equals to the weight of the object? Now remember, this object is not floating. It is completely immersed. It is different from a ship that is floating. We are talking about an object that is completely immersed. So for Archimedes' principle, it says that the buoyant force is equal to the weight of the liquid displaced. So let's take a look at diagram number 1. Are we concerned about the weight of the object now? No. That is not our concern. What we are worried about or what we are concerned about is the weight of the water displaced. Now, just a side point. Does Mr. Archimedes say that the buoyant force depends on the shape of the object? He doesn't say anything about the shape either. Does Mr. Archimedes say something about the buoyant force depends on how deep the object immersed into the water? No such thing either. All he says is the buoyant force is equal to the weight of the fluid displaced. So just remember this one simple concept. So are we concerned about the fact that the second pyramid has a mass of 2 kg? Does that bother you? It should not. The third one, 3 kilograms. Even if it is 30 kilograms or 300 kilograms, we are not concerned about that. We are not worried about that. But what are we worried about? Weight of water displaced. Now, in this case, we are told that the volume of all the pyramids are the same. So it means that the water displaced, the volume is the same in each case. And since the volume of the water displaced is the same, it means that the mass of the water displaced is the same. It also means that the weight of the water displaced is the same. Now, once you have got this, now let me just summarize for you over here. Alright, so in this case, we are familiar with the diagrams already. Okay, let me just summarize it in writing. So in each of the cases, we can say that the volume of water displaced is the same in each case. I just summarize it, I write down the word, it's the same. Alright, meaning in each of the 3 jars of water. So since the volume of water displaced is the same, we know that the mass of the water displaced is the same. So you write it down, it helps. And since the mass of the water displaced is the same in each of the 3 cases, we can safely say that the weight now is the crux. Therefore, the weight of water displaced is the same. So this means that even though the third pyramid has a bigger mass and a bigger weight, it doesn't matter, because we are talking about the weight of the water displaced. The key is the weight of the water displaced. Alright, so the weight of the water displaced is the same in each case. So if we look at the answer, which of the following statements is true? I'm sure all of you will be able to give me the correct answer. And you know that the buoyant force in P must be the same as the buoyant force in Q. It must be the same as the buoyant force in R. Okay, so look at the diagram again, even as we end this lesson. So you know that the buoyant force Fp is equal to the buoyant force Fq. It is equal to the buoyant force Fr. Very simple, very straightforward. It is simple and straightforward as long as you keep your eyes focused on what Mr. Archimedes is saying. Don't be distracted about other factors, about other quantities. So I'm sure you have understood better the meaning of Archimedes' principle now, and you are able to solve calculation problems using Archimedes' principle, involving Archimedes' principle. So with that, once again, I would like to thank you for your time, for your cooperation, and may God bless you.